Welcome to lecture series 8051 microcontroller. In today's session, we will discuss about ADC interfacing with 8051. Already we know the features and the pin details of 8051, right. So, today we will discuss about what is ADC and how this signal will be interfaced with the 8051. So, ADC is a analog to digital converter. Okay. So, analog signal which is a continuous signal is converted into digital signal, means zeros and ones. So, for that how we are using either the normal circuits or IC. So, here 8051 microcontroller only we are using. So, we are selecting the ADC IC which will support with the microcontroller. Okay. So, what are the signals we need to convert? So, by the name we are getting analog signal, right. It is a single signal, it might be any waveforms, will be converted into digital, means which will give the output as zeros and ones. So, you can connect it into the LED, you can view the its corresponding digital representations. Okay. So, based on the conversions it will be represented as either 8 bit or 10 bit ADC. So, the separate IC is available which is ADC 0809. So, with the help of this IC only today we are interfacing this IC with 8051, then we started to write the program. So, before discussing the IC, we will discuss what is ADC. ADC is analog to digital converter, right. So, how the function is performed. So, the continuous signal is continuously moving with respect to the time. So, first we are freeze the signal, that is the instantaneous signal. So, particular time we are taking the frame. So, the particular signal only we are taking, that is the instantaneous signal. From that instantaneous signal, right, we are applying the sample and holding, then we are taking the quantization and encoding. So, the three process mainly we are using the sample and holding and quantization and encoding signals. So, this is a instantaneous signal, it is one of the continuous signal. Okay. So, this kind of continuously moving signal will be taken as a instantaneous signal. This instantaneous signal will be converted into the sample. Sample means with respect to the frequency we are taking it as a sample signal. Okay. So, sampling means with respect to frequency of equal interval we are dividing. After taking the sample, now you are getting the signal like this. Okay. So, this signals this sample value, now you can read the corresponding magnitude values. Okay. So, the corresponding magnitude value we are taking, this value is converted into digital, right. Then only it take the next sample value. First it will take this magnitude value, this will be converted into the digital, then it will take this sample value, that is magnitude value. So, during this time, to avoid the confusions, it will take this magnitude and it will wait. After that it goes to pick this magnitude and it will wait, and this magnitude, this way only it was processing. Okay. So, this is called as a holding period. So, during this time it will hold, okay, to or it waiting for the complete conversion. So, this process is called it as a sampling and holding. Okay. Then after holding or after converting this, now we get the discrete value of its corresponding magnitude. Okay. That is called it as a quantization. The quantization will be giving the equal steps. Suppose you have 0 to 5 volts. Okay. So, it will be divided as equal steps based on the number of bits, then it will rise. This is a step size. So, this is a quantization with a uniform step size. By the quantization it will be, suppose 8 bit means 0 to 5 volts will be divided as 8, that is we usually doing V out divided by 2 power 8, that is 2 power 56. So, based on the number of bit positions you can divide it, this is a step size of the quantization. Based on this only we can define the resolution of the conversion. So, after getting the discrete value, the corresponding discrete value will be converted into the our required binary value. The conversion of discrete into binary is called it as a quantization, right. So, the continuous signal will be converted as a discrete signal. After discrete, it will be sampled with respect to the frequency of equal intervals. Then the sampled value which having the fixed magnitude will be processed to convert the digital signal. During that time, it has to wait instead of getting the next magnitude. So, this one is sample and hold. Okay. So, first this value will be taken and converted into discrete value, which is the process of quantization. Then it will be converted into its corresponding binary representation. In case of 3-bit representation means it will be represented with the 0 0 to the 111 values. Okay. So, each step size will be, you can give it as 0 0 0 0 1 with 3 ones. Okay. So, these 8 values will be divided by the 5 volts. So, maximum voltage how we are giving based on that response. This is a simple processing or steps involved to convert the analog into digital. Now, we will discuss about the ADC IC. ADC IC which is 0809 IC. So, based on that you can understand what is the input, what is the output, right. So, input will be one of the analog signal you will give it, right. Then we are expecting the output which are D0 to D7. So, digital data we are expecting. Okay. So, in this IC, so here I am giving the analog signal, we are getting the output signal. This is a simple process of ADC. In this IC, it has the facility of 8 channels. 8 channels we have, which are name it as IN0, IN1 up to IN7. So, what it represents, instead of a single channel, it has 8 channels. So, among the 8 channel, you can give your own input to any one of the channel, right. So, after giving that, so automatically 7 channel means which channel is processing now or which channel has the input, that also query, right. So, for that we have the 3 control signal, or you can say 3 selection signals, which is used to represent the bit positions. If all are 0 0, right, A is a LSB. So, if it is 0 0 means it will select the channel 0. If it is 0 1 0 means it will select channel 2. So, based on that 7 channels we have. So, it will select the 7 channels. So, any one of the channel will be selected. Okay. So, now according to this, it has a 8 channel. So, any one of the channel you can select. So, you can give your own input that will be converted. So, how can you control the processing of the conversion? So, for that it has a 3 signals, one is ALE, then SOC, then EOC, right. ALE is which is used to demultiplex the address and data signals. It should be high initially, okay. Then only we get the processing, that is why the ALE signal is connected. Then the start of conversion, which is usually initially you have to activate high to read the data, right. So, after initializing or after giving the input, suppose you are giving the input here channel 1, okay. So, suppose I am giving one of the sine wave. So, sine wave is ready, here I have given 0 0 1, okay. The corresponding channel also selected. After selecting the channel, the AL is high, then whenever the SOC become 1, then only it started to convert analog signal into digital signal. Okay. So, now I have applied the value 1 on SOC, now it start the conversion. We could not expect it will complete within the time, right. We have to wait till the getting the signal end of conversion. So, this end of the conversion signal will be active high. When the signal comes high, okay, or the signal is initially high, then it goes to low, represents the conversion is over. So, during that time it will be low. So, based on this rising signal, okay, this EOC is like a interrupt signal INTR. which are connected to the other processor or controller. So, what it represents, the conversion is over, now its corresponding digital value is ready. Okay. So, the data is available on the data lines. Now, you have to activate the read bar signal to read the data, which is from the controller or any kind of the processor you can activate. Okay. So, the ADC 0809 is a 8-bit ADC. Okay. So, 8 channels it have. So, 8 different inputs you can give it via this pin, that any one of the channel will be selected by this selection lines, which are ABC. Okay. Then data lines 8-bit representations we are getting the data line. Additionally, we have the 4 control signals, which are ALE, SOC, EOC and read bar. ALE is address latch enable, which is used to enable the latch. Okay. Once the latch is enabled means it will give the address lines. Then start of the conversion, which is used to initiate the conversion process. Okay. So, after giving the signal on the particular channel, now you have to activate the SOC. After activating that, now what we have set, the continuous signal will be converted into instantaneous, then sample and hold, then the quantization and encoding. After encoding, after getting the digital value, that value will be loaded on the D0 to D7. Now, it activate the EOC. EOC activated means it will interrupt the controller, it asks to read the data from the data bus. So, the read bar will be active to read the data. Okay. So, this is the process of ADC 0809 IC. Next, we will list the steps, what are the steps involved in the conversion, because you have to know these steps, then only you can easily write the program. So, first we have to select the channel by the input bits ABC. Okay. Because we have 8 channels, among the 8 which channel you want, that should be activated by using the 3-bit representations. Okay, ABC. After channel is active means now the input is ready. Input is ready means we have to start the process of conversion. Before that we have to activate the ALE. The ALE signal should be high. Okay. If the ALE signal is high means how we can activate, you can assign any one of the ports. Okay. Suppose I have assigned the 3-bit representations for port 2. If suppose port 2 is assigned means port 2.0, port 2.1 and port 2.3. Okay. These 3 bits are assigned for the bit positions A, B, C. Okay. In case of channel 1 means how we are activating channel 1. Channel 1 means A should be 1, B 0, C 0, right. So, this will be activated by simple instructions which are bit enabled, right. Suppose you can give it as set bit B 2.0, then clear bit P 2.1 and clear bit P 2.3. So, by using these instructions, now you are activating the channel 1, okay, which is in the IN 1. So, after that now I think these are the signals you can give it from the port 1. So, port 1 you can give it as port 1.0 for ALE signal. So, if you are giving port 1.0 for ALE, okay, then you have to set bit, because this should be high for activating the latch. So, set bit BP 1.0 means automatically it will activate it. Okay. Then you want to activate the start signal, which is the start of conversion. The start of conversion signal might be converted into or connected with the P1, we will take it port 1, right, port 1.1. So, set bit of port 1.1 you can take it. Okay. So, now ALE is active, then start signal also active. Now, it start the conversion, now only it starting the process. So, it will take the time. So, we have to wait and monitor the end of the conversion signal become high. That is, suppose you are connected with P 1.3 means you can give it set bit. Initially the signal is high, right. Whenever the signal goes to low, then only it rise the interrupt signal. So, when the interrupt signal is rise means what it represents, we have to read the digital data which is available on D0 to D7. Okay. So, these are the 5 steps for converting the analog signal into digital. First we have to select the channel by the 3 bit representations, then activate the ALE signal, then activate the SOC signal, then we have to wait and monitor the condition of EOC signal, which is end of conversion. When it goes to low means it represents the conversion is over. So, initially we have to set the bit positions, then we have to wait till going to low. Then when you get the value of low, it represents the data is ready. So, you can activate the read bar signal to read the data. The same process we will discuss with the waveform representation. In the waveform, the clock represents what? It is a high low signals, right. This is a one clock period. So, continuously we are applying this kind of continuous clock. Okay. Now the channel is selected. Now we are activating the ALE signal. ALE signal will be high for one period. You can take it as this is a one period. So, it will goes high then low period. Now, your required address will be enabled. This is the address signals you can say. Okay. Now, after that we are activating the SOC. SOC signal is high. Okay. Now, the conversion will start. Initially we are initiating the EOC as a high signal, right. So, after the particular time it goes to low for one period, then it comes to the high position. So, during this period now we have to activate the RD bar to low to read the data. Okay. By this we are getting the data. These are the wave representation of analog to digital conversion process in the IC 0809. Okay. So, first we are applying the clock signal, then activating the ALE for one period, then we will get our required address, then activate the SOC, then we have to wait for this period. Okay. So, after it goes to low, now we are activating the read is active low signal, that is why during the low process, during the low period it will read the data. I think you get the idea of ADC of 0809, already we know 8051, right. Now, we will start to interface both IC. So, I will take this is the IC which is IC 8051. Okay. So, here I have the IC which is ADC IC 0809. Okay. So, here I will get the input signal channel 0, input channel 1 up to input channel 7. Here I will get the 3 bits for selection. Then here I will connect the data lines D0 to D7. Okay. Then we want to activate the remaining control signal ALE, SOC, EOC, and here sometimes they were give it as a output enable, or you can say it is a read signal. Okay. So, this is the interfacing. Now, you have to decide what are the ports to be interfaced with the 8051. Now, I assign port 0 for getting the output, the digital data. Okay. Then port 1 will be used for the remaining signals. So, port 1.0 for ALE, port 1.1 for SOC, port 1.2 for EOC, right. Either port 1.3 you can give it as a read bar signal, or already in the port the read bar signal of 8051 is connected with the output enable of ADC signal. Okay. Then remaining 3 signals which are port 2 I will take it, port 2.2, port 2.1, port 2.0. Okay. So, this 2.0 is connected with the A, 2.1 is connected with B, this one is connected with C. So, now we have made the physical connection between the ADC and 8051. Okay. So, what I have done, this is for the output initialization. for the digital data. So, the digital data, converted digital data will be available on the port 0, then port 0 is initialized for the output to get the digital data, port 1 for the control signals, right, port 2 for the selection signal. Okay. So, keep this in mind. So, this is a connection between 8051 and 0809. Now, we are planning to write the program. So, for writing the program, what we have to do? We have to activate the 4 steps, right. So, first I want to initialize the channel. So, how I have given the port 2 for the channel, right. So, you can give it as a port 2, port 2.7 to port 2.2, port 2.1, port 2.0, right. Either these 3, simply I will say these 3 are only for channel selections, remaining are not used. So, you can assign it as a 0 0. So, if all the bits, now I ask you to use the channel 1. So, 0 0 1 I will use it, here also 0, right. Okay. So, now its corresponding value is 0 1. So, by using the port 2, so move port 2 comma 0 1 H, only 3 bit positions we are using to select the particular channel, remaining are not used, right. Then this is one more instruction we have to give, P naught, which is for the digital output. I will initialize as a 0 0, this is initialized for the digital, this is for channel selection. Okay. So, I have initialized one of the channel, then I initialized the channel selection, right. Then what I have to do? Now, I have to start the process. So, how to start the process means I have to first activate the ALE signal. ALE signal is connected with ALE is connected with P 1.0, then SOC is connected with P 1.1, EOC is connected with P 1.2. Okay. So, you keep in mind to write the program. So, we are initialized the output and for channel selection. Now, we have to activate the ALE signal. So, by giving the set bit, which is port 1.0, right. So, I have to maintain this for a few seconds. So, I will initialize the no operation with a clear signal P 1.0. Okay. This is for ALE. Now, I have to activate the SOC, right. SOC also the same process we are doing, set bit P 1.1, then no operation, then clear P 1.1. This is for SOC. Again I have to give the activation signal for end of conversion. So, I will give the end of conversion signal set bit P 1.2, right. Now, the process what I am doing till the carry is set, I want to do the process. So, repeat the process, not below the carry, not carry bit is set. Okay. So, what it represents, I have activated the EOC signal, which is continuously high, right. Whenever the bit sets, what it represents, it goes to low. So, during that time it will exit from the loop. So, for that we are giving, if the carry is no carry means it is not set, then we are repeating the process. Once it set, we are exiting. Now, after that, now the digital data is available on the P naught. Whether you want to store in any one of the register, you can store it by giving the instruction move R3 comma P naught, or if you want to store in any one of the specified location means you can give it move 40 comma P naught. Okay. This is for memory storage, this is in any one of the register. Okay. So, this is a way we are developing the coding to read the data from the particular channel. Suppose I am asking you to read the data from the 4th channel, means what you will do. So, 4th channel means here I have to give the bit position of 100, then you read it as 4. So, instead of 1 I have to give it as a 4. Okay. So, this is the one way, by changing the channel we can read it. Suppose I am asking you to read all the channels. So, all the channels means I have to initialize the 8 values, right. So, you initialize one of the counter, here you can give it as a move R3 comma 0 0, you can initialize it. After each process you can increase the R3. So, initially you can get it as a 0, then by increasing this you will get the channel 1, then increasing channel 2, channel 3, you can do it. So, this process after storing you can give it as compare and jump not equal to R3 comma 08, right. Then here till the process you have to repeat it. So, this way the same program, by inserting a counter you can read all the channel values. Okay. So, in today's session we have discussed how to convert the analog signal into digital with the help of the IC 0809. It has 8 channels with the 4 control signals. So, among the 4 channel, one of the channel we have to read it to get the input signal. So, for the corresponding ports you have to assign it and activate it. Then the 4 control signals which are ALE, SOC and UOC you have to activate, right. Then one of the port is initialized for getting the digital data. So, once you are getting the low on UOC, then it indicates the data is completed, the conversion is completed, the digital data is available on the data lines. By using the read bar signal you can read it. Okay. So, by this way you can interfacing any kind of ADC with the 8051. So, I hope you understand how to interface and how to develop the coding for conversion. Thank you.